All right, I'm going to go over it. Hopefully you have enough time to do this. I'll do at least a couple, right? So here we go. Use your knowledge of polygons, triangles, etc. to answer the following. Calculate each indicated angle. So let's see, sometimes it's best to start strategically. So we're going to count first 1, 2, 3, 4, 5, 6, 7 sides of that polygon, right? So not the dashed lines. So we have that's actually called a heptagon. So here we go. So A is an interior angle. So angle A would be n minus 2 times 180 divided by n. So angle A is 5 times 180 divided by 7. That's 128.57 degrees. Okay, so we've got that figured out. It turns out that B is simply an exterior angle, so you use the exterior angle formula, or I'm just going to use this property, right? The fact that they do form a, they're supplementary, they're straight angle combined. So there we go, B is there. And angle C, right, is easily found because I know this is an isosceles triangle. So technically this is 51. This is also, we can call this B for all intents and purposes, right? They're the same. So C is simply 180 minus 2 times 5143, right? And so angle C is 180 minus, there you go, that's 77.14 degrees. So you got that as well. I will say this straight angle, and here I will just say sum. It's just good practice, right? To sum of triangles 180. If I ask you to justify, there it is. This one would be interior angle of heptagon, right? There we go. So we've got that figured out. And then for D, again, it spans, or these two sides span over two sides. So you kind of want to just focus in on this. Call this X if you want. So angle X is 360 divided by 7. It's going to be the same as the exterior angle, right? You can go ahead and just try it. If not, just trust me, right? And so therefore angle D is 2 times 5143, right? And that would be 86 at the end, and then 102, right? 102.86 degrees. That's D right there. Okay, so done. Hopefully you've followed there. I will just say this, spans over two sides, therefore 2 times central. Okay, explanation there. Okay, for B, and again, you can pause this, right? If it's too fast, you can slow me down. Let's see here. E is not an interior angle because E is here. Okay, so don't make that mistake. So what could we find first? I think I'm going to be inclined to find A. I see that that's a central angle. It spans one side. Okay, so I'm going to figure that out first. 360 divided by, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. N is equal to 9 right off the bat, so that would be 40 degrees, okay, for A. Got that figured out. I think I'm going to find E right away. And this is where the markings aren't there, but this only works, like you can only find A and split it into 9 if this is a regular polygon, right? Because then every central angle all around is the same, it's 40 degrees. That means that, right, from the center to this corner should be the same as from the center to this corner here. So we actually have an isosceles triangle in our hands here, okay? So to find angle E, I will simply go 180, okay, minus angle A, and then I will divide that in half because these two angles are congruent because the angles across the congruent sides must be congruent also. So angle E would be 180 minus 40 divided by 2. Make sure you do this in brackets, right? It's invisible brackets there. Angle E is 140 divided by 2, which is 70 degrees. And voila, you're done. You found E. So you found A and E. For A, I'm just going to make a note it's a central angle. Okay. And here, I'm just going to make a note that it's an isosceles triangle. I used sum of triangles equal to 180, right, to figure out E here. So I don't know if you want to kind of just chunk this up like that, chunk that up like that, and keep your work organized, right? Next, I'm inclined to find B, and B spans, right, the two sides that create angle B span over 1, 2, 3 sides. So it's really 3 central angles in here. So it's basically 3 times A. Okay, so angle B is actually 3 times a central angle. And that's 3 times 40 degrees, which is 120 degrees. So you're done there too. Okay, so B is done. C, I don't know, you can say, right, 1, 2, 3, 4, 5. It spans 5 sides, so it's 5 central angles, sure, but let's always keep everything, our whole option, all of the options available. And you can tell that if this is your central angle, all around that point, it's 360 degrees. So I'm just going to go 360 degrees minus angle A minus angle B. That remainder should be angle C. You should get the same answer regardless. So minus 40 minus 120, right? And what do we have here? This is actually 160, so that'd be 200, right? 360 minus 200, sorry, 360 minus 160 is 200 degrees, so there we go. You found C. Okay, so let's kind of clean that up, just section it off, and we're left with C and D. Now, this is where you can introduce variables, right? If they're not given, go for it, right? You're making it work. So I will call this angle X here, that interior angle. Maybe we don't need to do that. I was going to use the fact that these are supplementary. Let's just skip that. Yeah, I don't want to make it too busy. C is an exterior angle. Oh, I have 2 C's. I just noticed that. Let's call this, we'll call this X to distinguish. Okay. So angle X is going to be 360 divided by 9, which is 40 degrees. Same as my central angle here, right? Exterior angle. That's the justification. So X is done, right? And then again, these two are the same because, right, if this is a regular polygon, then going out this way and that way, they should be equal in length. So angle D is going to be 180 minus 2 times 40, right? We're going to assume that both of these are going to be 40 because this is also an exterior angle. Same as this one here that we renamed X. And so actually it's the fact that these both being exterior angles and then both being 40 that gives the result or lets us conclude that these two sides must be equal, right? Because congruent angles will have congruent sides across from them, right? And that's where we come up with D. Angle D is 180 minus 80, so it's really 100 degrees for angle D, and we found them all, okay? Hopefully this wasn't too confusing with the renaming and everything. That's my bad. Let's go back here with some more examples. All right, so I don't know. There you go. A regular polygon has interior angles of 168 degrees. Determine the number of sides. So if we use the formula, right, for the interior angle, we just plug in 168. We substitute that in here. So it's 168 is equal to n minus 2 times 180 over n. We can multiply both sides by n. Cancel that out. That's 168n. We distribute this, right? The 180 times n is 180n. 180 times negative 2 is negative 360. You'll see a pattern if you do enough of these. Bring the 180 over, right? So it's 168n minus 180n is equal to negative 360. You're left with negative 12n is equal to negative 360. Divide both sides by negative 12. And n is equal to 30 sides. That's one way of doing it. Or we know that interior and exterior angles of a polygon are supplementary. So the exterior angle is 180 minus 168. So the exterior angle is 12. So you will notice that pattern, right? Like some numbers will end up on the other side. And now I know that the formula for exterior angle to figure out the exterior angle is 360 over n. So this substitutes in there, like so. Put the 1 here, 360 times 1 divided by 12, right? Cross multiply and divide. And n is equal to 30 sides also. So regardless of how you do it, you should be able to come up with the same answer. Next we have regular polygon has a sum of 7200 degrees, calculate the number of sides. So the sum of a polygon is simply found by using that formula. The 7200 substitutes in there. I call these backwards, right? And you can choose to distribute, but I would divide both sides by 180 here, because there's a number on the other side. If this number had a variable attached to it, I would have probably first distributed here. But if it doesn't, then you just go for it, right? So 7200 divided by 180, that's 40, and that's n minus 2. That's what you're left with. Add 2 to both sides. N is equal to 42, right? So 42 sides. Done. And the last one, solve for the indicated angles. And I hope I didn't double up on variables here. I did double up, but it's for a reason. It's for a reason here. Now, let's focus in on the main polygon here. So let's outline the polygon that we're going to consider first and foremost. This one here, because there's dashed lines that come out of it, but we just want to focus on this one. So 1, 2, 3, 4, 5. You can tell right off the bat that this is not a regular polygon. How so? Well, you've got a 90 and a 115, right? Two things need to be true for a regular polygon. All angles need to be the same. All side lengths need to have the same length. So angles the same, lengths the same. And it fails the angle test, so this is not regular, right? This is irregular. Okay? Angles are not all congruent. So right off the bat. But the sum of a polygon, that formula still works. So 1, 2, 3, 4, 5, 6. N is equal to 6. The sum of a 6-sided shape would be n minus 2 times 180. So that's 4 times 180 essentially, which is 2 times 180 would be 360, right? So 720 degrees, because it's two 360s basically, or 4 times 180. So that's the sum of all the interior angles in this particular polygon have to add up to 720. So here's what you do. You're like, okay, well, let's see, 720 should be equal to, let's see what we have. We have let's go with the 115 up here, plus two 90s, two 90-degree angles, right? Plus 125, plus x, right? And there's only one variable, so you'll be able to isolate it. So 720 degrees is equal to, let's add it up, 115 plus 180, plus 125. That's all of these numbers add up to 420 plus x, and x would just be 2x, right? So bring the 120 over, or subtract 420, say 120, subtract 420 from both sides, you end up with 2x. This ends up 300 degrees, right? Divide both sides by 2, and x is equal to 150 degrees. So you've actually found both of the missing angles here, and they should add up to 720. Is the polygon an irregular? And the answer is not regular, right? Irregular, because angles are not all congruent, right? So you're done there. So we're going to solve for the rest here. For y, right? Let's see here. I'm going to just dedicate some space here. Angle y lowercase would just be 180 minus 125. Okay. And that leaves me with 55 degrees. Okay, so we've got that figured out. Angle z, it'll be different because x is 150, right? So angle z will be 180 minus x. Z is 180 minus 150. So angle z is 30 degrees. Okay, so watch how that is different. And then m can be used by using the sum of triangles, right? There's a triangle formed there. Angle m is simply 180 minus 55 minus 30. So this adds up to 85, right? So that'd be 95 degrees for angle m, and you've solved it. All right, hopefully this helped. Have a good one.